So before we start, I have some reminders for you. Monday is a holiday, campus is closed, so there's no class, and won't have any other classes, including mine. Tonight, your homework for basic derivatives is due. On Monday, your quiz 4 is due. Remember, you don't have to wait till Monday to take that. You can take that anytime. So if you want to enjoy your long weekend, then finish your homework and take that quiz today, and you can have 3 days off. Because I'm not giving a handwritten quiz on Monday. So the one where you go to Gradescope and you just do that one thing on Monday, that's not happening this week. So Monday you can actually take a day off as long as you do quiz number 4 before that. Okay, so there you go. Happy long weekend. I also will be like, I don't know what my internet will look like on Monday, so I can't guarantee I will send you a reminder to take the quiz on Monday. I will try, but I don't have, I can't get to it like from my phone. So if my, if I don't have Wi-Fi somewhere, then I can't send you an email. So try to do something to remember, like take it today. Okay, so we are going to start the day with the quizzes. Pause the recording while we do the quizzes. Zoom recording. All right, so I want to do a couple of examples that are like things that you've seen in the homework that we haven't quite handled yet. So we're not learning anymore. We don't have to learn any more rules. You know all the rules you need for this week. Basically, the power rule, the product rule, the quotient rule, all the trig functions, and exponentials and natural logs, right? Those are your sort of rules of the week. We're going to learn another rule next week. So it's super important that you practice those basic rules that we have from this week, because next week life's going to get a lot harder. So what we're going to do is just do a couple of examples, and then I'll take your questions from homework. So this guy says a car driving along a freeway with traffic has traveled S of t equals t cubed minus 6t squared plus 9t meters in t seconds. So that's the position of the car. It says determine the time in seconds when the velocity of the car is 0 and determine the acceleration of the car when the velocity is 0. If you know the position of a car, how do you find its velocity? Take the derivative. If you know the position of a car, how do you find its acceleration? Take the second derivative, right? The derivative of the velocity. Okay, so I'm going to start by finding the velocity. I'm going to try. There we go. Velocity is the derivative. The derivative of this function is 3t squared minus 12t plus 9. Great. Okay. Acceleration is going to be the derivative of velocity. The derivative of this function that we just found is 6t minus 12. Great. Okay. Part A says determine the time when the velocity is 0. What do I want to do with this velocity equation? Set it equal to 0, not plug in 0, right? It doesn't say determine the velocity when the time is 0. It says determine the time when the velocity is 0. So I'm going to set this equation equal to 0. 0 is 3t squared minus 12t plus 9. I'm going to solve this quadratic using my favorite quadratic solving method. I don't care what yours is. You can pick. I'll try factoring. I'm a pretty good factorer. T minus 3, t minus 1, t equals 3, t equals 1. That's what I got. I got that the velocity is 0 at 2 places, t equals 3, and t equals 1. If I had graphed this position function here, t cubed minus 6t squared plus 9t, I should have seen 2 humps, one at a top and one at a bottom. And that would have told me that at those 2 humps, the velocity was 0. So I set it equal to 0. If you don't like factoring, don't try to learn it now. Go ahead and use a quadratic formula and solve that. Or put it in Desmos and see where the zeros are on the x-axis. Any of those methods work. Okay, so there are 2 times when the velocity of the car is 0, at t equals 1 second and at t equals 3 seconds. Okay. Part B says determine the acceleration when the velocity is 0. So these are the 2 places, t equals 1 and t equals 3. when the velocity is 0. I'm going to find the acceleration at both of those places. So I'm going to take both of those values and plug them in for t. -6, +6. So the first time the velocity is 0, they are decelerating at a rate of 6, whatever the units are, meters per second squared, yeah. And then at the second time, they are accelerating, they have a positive acceleration at a rate of 6. So the important things to remember are velocity is the derivative of position, acceleration is the derivative of velocity, or the second derivative of position. Okay, let's try again. So here is a table of values about these two functions f and g. So I don't know what these two functions are, right? I don't know anything about their equations. All I know is that when I plug 2 into the function f, it spits out 2. When I plug 4 into the function g, it spits out 4. When I plug 1 into the derivative of f, it spits out 2, right? When I plug 5 into the derivative of g, it spits out 5. That's all I know about this function. I don't know the equation of f. I don't know the equation of g. I don't know any other values. Like if I wanted to find out what f is at 6, I got nothing, right? This is all I know about these functions. So what they're going to do is mix these functions together. And they're going to have you find pieces of information about new functions made from these old ones. So here's a new function, 2x plus 4 times f of x. It wants you to find the derivative of this new function at x equals 1. What do you know about derivatives? If you have like numbers multiplied and added together, what can you do with derivatives? What do you know about derivatives? No?
Product rule.
Sure. The product rule. Which one of these do you think I'm going to need the product rule for?
The first one.
I'm not going to need the product rule for the first one. How come?
The third one.
The third one. So what's different in the third one than the first one?
It's because it has two variants.
Yeah, this has x's in both of these parts. This guy just has numbers times x's and numbers times functions, right? So if you go back to the first day of notes on Monday, we had that box with those derivative rules. And remember I said if you have a constant times a function, the constant just stays there and then you take the derivative. If you have two functions added together, you can take the derivative of each part separately. So if I'm going to do this first one, I'm going to say the derivative of 2x is 2 plus the derivative of 4f of x is 4 f prime of x. Yeah? So if my function is 2x plus 4f of x, the derivative is going to be, derivative of 2x is 2. The derivative of 4f of x is 4f prime of x. Now what am I going to do? Plug in 1 for x. I'm going to plug 1 into this equation for x because it says x equals 1 here. So 2 plus 4 f prime of 1. Okay, I'm going to have to go back to my table and look for f prime of 1. So what on my table gives me f prime of 1? 2, right here. Yeah, f prime of 1 is 2. Okay, so this is 2 plus 4 times 2, 10. So that answer would be 10. Okay, let's try again. So the first thing I do is take the derivative. Do not plug in any numbers until after you take the derivative. Okay, the first thing you do is take the derivative. To take the derivative of this guy, I'm going to do each part separately. What's the derivative of x squared? 2x. What's the derivative of 2f of x? 2f prime of x. What's the derivative of 5g of x? 5g prime of x. Okay, so this guy's going to look like 2x plus 2f prime of x minus 5g prime of x. Okay, now I got to do this part. Let me get a new color. I got to do this part, plug in 3 for x, right? Everywhere I see an x. So this is going to be 2 times 3. I'm plugging in 3 for all the x's. Plus 2f prime of 3 minus 5g prime of 3. Okay, so I'm going to go up to my table now because I need this value, f prime of 3, and I need this value, g prime of 3. So I'm going to go up to my table and look for f prime of 3 and g prime of 3. Here's my f column. Here's my 3 column. G prime of 3 is 4 and f prime of 3 is 1. So I have 2 times 3 plus 2 times 1 minus 5 times 4. So some numbers I had to look for in the table. Other numbers just came from x, and other numbers were already part of the formula. Okay, so 6 plus 2 minus 20 is negative 12. Okay, what you should notice about these last two guys is they need rules, right? They don't just need the adding and subtracting. In this function, I have an x and an f of x multiplied together. I'm going to need to use the product rule. In this function, I have an f and a g divided by each other. What rule am I going to need? The quotient rule. So for this guy, I'm going to need the product rule. For this guy, I'm going to need the quotient rule. Okay, let's do it. The product rule says derivative of the first. In this case, my first function is x, and my second function is f of x. So the product rule says derivative of the first. What's the derivative of x? 1 times the second, f of x, plus first x times the derivative of the second, f prime of x. Okay. Once I take the derivative, then I'm going to plug in my number. In this problem, my number was x equals 4. So I'm going to plug 4 everywhere I see an x. So 4 is going to go in 3 places everywhere I see an x. I'm going to have 1 times f of 4 plus 4 times f prime of 4. 1 times f of 4 plus 4 times f prime of 4. So all of those x's got replaced with 4s. Now I'm going to need my table. I'm going to need my table for f of 4, and I'm going to need my table for f prime of 4. That's funny. There you go. I'm going to need my table for f of 4, and I'm going to need my table for f prime of 4. Okay, so let's go up to our table. Here's the 4 column. I need f prime and I need f. So f of 4 is 1. F prime of 4 is 5. F of 4 is 1. F prime of 4 is 5. So this is going to be 1 times 1 plus 4 times 5. 21. Okay, here we go. Last one. This guy needs the quotient rule. The quotient rule says bottom, g, times the derivative of the top, f prime, minus top, f, times the derivative of the bottom, g prime, all divided by G squared. Okay, I am plugging in another color, pink. Sure. X equals 2. So all of these places need a 2 inside of them. So G of 2, F prime of 2, minus F of 2, G prime of 2, divided by G of 2 squared. So I'm going to go look in my table for all of these values. I need everything from the 2 column, right? I need G of 2, I need F prime of 2, I need F of 2, and I need G prime of 2. I'm going to need all of the values from the 2 column. Let me see if I can get it. 2, 2, 4, 3. Let me write it over here. 2, oh my gosh, 2, 2, 4, 3. This was F, G, F prime, G prime. Okay, so for G of 2, I'm using 2. That was this guy right here, that 2. Times F prime of 2 is 4. Minus F of 2, that's that guy right there, 2. Times G prime of 2, that's the bottom guy, 3. All over G of 2, 2 squared. Okay, 2 times 4 is 8, minus 6 is 2, divided by 4, 1/2. Oh, I should have inserted pages before. I want you to be careful when you're doing your homework, because in your homework, there are some problems where they ask you to do the derivative from a table, and there are other problems where they just ask you to use the values from the table and not even take the derivative. Okay, so just look out, like, do they put the prime on there or this derivative notation or not? Okay, so be on the lookout for that. Okay, I am ready for questions from your homework. 19. It's gonna go in up here. It is what it is. 11. 9, 9, 11, 19, 3, 12, 14, 3, I can't do it. 3, 9, 11, 12, 14, 19. I get them all? Yes? Okay. I have to get my little snipper thing out. That's a lot. Okay, I'm not ready. This is 12. I cancel. 3. No. Nine. They're going in random order. You get what you get. 11. I think I just have 19 left to copy. 14. I have 14 to copy. $19. Hit it. Okay, here we go. Oh, that page is blank. Of course it is. And that page is blank. Of course it is. What happened? Why are there so many blank? 12. I'm starting with 12. Here, 12. If f is a differentiable function, find an expression for the derivative of each of the following functions. When you're submitting your answer, put in f of x as f and f prime of x as g. Okay, the first one says y equals x squared f of x. How do you take the derivative of y equals x squared f of x? I need the product rule, right? This is a product. I need the product rule. Y prime is going to be derivative of the first, 2x times the second, f of x, plus first, x squared, times the derivative of the second, f prime of x. In here, they tell you that if you have f of x, write it as f. And if you have f prime of x, write it as g. So when I'm submitting, I'm going to say 2xf plus x squared g. Whose question was number 12? I'll do one more part. Which part do you want? D. Yep. D. D says 1 plus x f of x over square root of x. You can do D two ways. You could use the quotient rule, or you could rewrite it and not use the quotient rule. Which one do you want to do? Quotient rule. Okay, great. Okay. Before I start the quotient rule, I'm going to say that square root of x is the same as x to the 1/2. Great. Okay. Quotient rule says bottom square root of x times the derivative of the top. The derivative of 1 is 0. How do I take the derivative of this x f of x guy? Product rule. Dang. 1 f of x plus x f prime of x minus top 1 plus x f of x times the derivative of the bottom. Derivative of x to the 1/2 is 1/2 x to the, so close, negative 1/2. 1/2 minus 1 makes negative 1/2. All divided by the bottom function squared. Okay, remember these two pieces up here. Anytime I see an f of x, I'm going to write it as f. And anytime I see an f prime of x, I'm going to write it as g. So if I was going to enter this guy, I would say square root of x times f plus xg minus 1 plus xf times this thing, 1/2 x to the negative 1/2, divided by square root of x squared is x. Okay, next we've got 3. Okay, 3 says 1 over y squared minus negative 2 over y to the 4th times y plus 7y cubed. I can do this problem two ways. I can use the product rule, or I can multiply it out and then not use the product rule. I don't care which way we do it. This was number 3. You want product rule or multiply out? Yeah, okay. So before I start the product rule, I'm going to take that first piece and I'm going to write it so it looks like things I can take the derivative of. 1 divided by y squared is the same as y to the negative 2. And then I have minus minus, which makes plus 2y. If 4 is in the bottom, it's going to be negative 4 there. Y plus 7y cubed. I have to try to write really tiny. I'm not very good at it though. So my two functions are this y to the -2 plus 2y to the -4 and y plus 7y cubed. We're going to find the derivative now. Yeah, I didn't do any derivatives yet. Remember, we do all the rewriting and then we do derivatives. Yep. Okay, so product rule says derivative of the first. So I have to take the derivative of this guy. -2y to the -3 minus 8y to the -5. Yeah. Times, leave the second function alone. Plus, I'm going to go on the next line. Leave the first function alone. Times the derivative of the second function. Derivative of y is 1 plus 7 times 3 makes 21 y to the second. Again, you don't have to simplify. If you enter it in just like that, should be good. All right, let's see what's next. I'll give everybody a chance to write. Still see people writing. Take your time. There's blank pages next. 3 of them. I don't know what happened. 11. Ooh, 11 says find d2y dx squared. What did that notation mean? You remember? The second derivative. Yeah, the derivative of the derivative. Okay, so I'm going to start by finding the first derivative. What do I need to use to find the derivative of x cosine x? The product rule. Anytime you have two variables multiplied together, you need to use the product rule. Okay, so derivative of x is 1. Leave the cosine alone. Plus x times, what's the derivative of cosine? Negative sine, perfect. Negative sine x. This is one time where I'm going to tell you to simplify, because your life is going to be easier if you simplify when you have to take the second derivative. If you don't have to do anything with it, leave it as is. But if you've got to use it again by taking another derivative or setting it equal to 0 or something like that, then I say simplify. So 1 times cosine x is cosine x. This negative can come out here and be subtraction, x sine x. Okay, I'm going to do the derivative again. Notice what happens over here. I'm going to need the product rule again. And I have a product rule with a negative here. So I'm going to make sure I put a bunch of big parentheses. Okay, what was the derivative of cosine? Negative sine. Good job. Minus. I'm going to put a big set of parentheses because everybody in here gets subtracted. Okay, derivative of x is 1. Leave the sign alone. Plus x times the derivative of sine? Cosine. So now I can leave it just like that, or I can distribute this negative. Don't forget to distribute that negative though, because if you try to do negative and then you leave that plus here, if you don't put those big parentheses in, you're going to get it wrong, because you're going to forget that that guy is a minus and not a plus.
That 1 times sine of x.
Yep, because the derivative of x is 1.
You get cos of x at the beginning.
Over here,
Yeah.
that was 1 times cosine up there. From that, because that was the product rule. So we did derivative of x, which is 1, times the cosine, plus x times the derivative of cosine. So that was the product rule for the first part. Okay, number 9. Okay, number 9 says evaluate f prime of 3 and f prime of 4. To evaluate f prime of 3 and f prime of 4, you should take the derivative and then plug in 3 and plug in 4, right? So to evaluate f prime of 3 and f prime of 4, take the derivative, plug in 3 and plug in 4. I'm not going to use the quotient rule. I'm going to rewrite this guy, cube root of x to the 4th. What power do I put here if it's cube root of x to the 4th? Upside down, 4 over 3, yeah. And then I'm going to divide it up into pieces. Remember how we did that before? We said 6x cubed over x to the 4/3 minus 7x squared over x to the 4/3. So I haven't taken any derivatives yet. I'm just doing algebra right now. When you divide two things, what do you do with their exponents? Subtract them. So I'm going to do x3 minus 4/3. So in your calculator, do 3 minus 4/3. 5/3. And then I'm going to do the same thing for this guy, 2 minus 4/3. 2/3. So all of that was just algebra, right? I didn't do any calculus yet. I didn't take any derivatives. I just did some algebra. So I rewrote that exponent. I divided it into two pieces. The only time you can divide into two pieces is when you have one term in the denominator. If you have pluses or minuses in the denominator, can't do it. You have to use the quotient rule. And then I just subtracted exponents to get it look like that. Now I'm going to take the derivative. F prime of x. Bring the power in front. So 6 times 5/3 is 30 over 3. And then subtract 1 from the power. 5/3 minus 1 is 2/3. Minus. Bring the exponent in front. 7 times 2/3 is 14/3. 2/3 minus 1 is negative 1/3. Once I have this, all I have to do is plug in 3 and 4. So you can do that in decimals. Plug in 3, get your number. Plug in 4, get your number. Plug it for the x. Yep, plug it in for the x. I think there'll probably be different numbers. Oh, both ways. You mean if you use the quotient rule? Yeah, you should get the same number. Yep. Okay, let me write it down. Plug in 3 and 4 for x. Great. 19. You have to squint really hard to read 19. Let me make it bigger for you. 19 says, suppose since January 1st, 1960, the population of Slim Chance has been described by the formula P equals 22,000 times 0.95 to the T, where P is the population of the city T years after the start of 1960. At what rate, when you see the word rate, what should you be thinking? Derivative, great. At what rate was the population changing on January 1st, 1989? If it's January 1st, 1989, how long has it been since we started? 29 years. So rate tells me take the derivative. How do you take the derivative of this guy? The constant stays there. What's the derivative of 0.95 to the T? 0.95 to the T times ln of 0.95. Yeah. So this is the rate. Remember, the derivative of e to the t is e to the t. Anybody that's not e, you put that natural log at the end. So this is the rate, and I have to plug in the years. How many years? 29 years. So then just plug in 29 years. P prime of 29 is whatever number your calculator tells you this is. I got 29 because they told me that I started in 1960 and they wanted to know where I was in 1989. So I did 1989 minus 1960 and that gave me 29. Okay, let's see what I got left. 14. Let f of x be this function, x minus 2 times 4x plus 3. Find an equation for the tangent line to the graph of f at x equals 12. Find an equation for the tangent line to the graph of f at x equals 12. How are you going to find the slope of the tangent line? Take the derivative and plug in 12, right? So remember the slope is the value of the derivative at that point that they gave you. So I'm going to take the derivative of this function, I'm going to plug in 12. Then I know that x is 12. How am I going to get the y value? Plug 12 in to the original equation here, yeah? Okay, so I'm going to do two things. I'm going to take the derivative. So the slope, I'm going to take the derivative, plug in 12, and then to get the y value, I'm going to plug 12 to f of x. Okay, that one's easier. 12 minus 2 times 4 times 12 plus 3. So 10 times 51, 510. Okay, so my point is 12 comma 510. Okay, I can do the derivative two ways. I can multiply it out and take the derivative of each piece, or I can use the product rule. Either way is fine. Doesn't matter, whichever you think you're better at. I'm just going to do the product rule because I don't want to do any multiplying. Product rule says derivative of the first, 1, times the second, 4x plus 3, plus first, x minus 2, times the derivative of the second, 4. Great. And now I'm going to plug in 12. The slope is going to be what I get when I plug in 12. This is 40. This is 51. 91. I got 91 for my slope. Okay, the last thing to do is to find the equation of the line. So I know the slope of the line is 91. I know the point is 12 comma 510. I can find the equation by doing y minus 510 is 91 times x minus 12. Y equals 91 times x minus 12 plus 510. I think if you put it in that way, you're going to get it right. If you distribute, you can do that too, right? So you could distribute the 91 and then combine like terms. I don't know if I can do 91 times 12. Let's see, 910 plus 182 is 1092 plus 510. 91x minus 582. Probably totally wrong. Check it on your calculator.
1092, right?
Yay. Common Core. I'm too old for that. So I think that the equation is 91x minus 582. And I think that brings me to the end of, yep, that's the end of my pages. I have time for one more if someone didn't get to shout out their number before. I could do, yeah, I can. Okay. That's my little snipper. I gotta go find those blank pages, remember? Found one. Okay, ugh, can't believe that. Ay, ay, ay. 18. Oh, 18 is a lot like the one we did with the table, except there's no table. We're just gonna use those numbers they gave us. Yeah. So if I want to find the prime, where my function is 3f plus 4h at x equals 2. So I'm gonna find the prime, the derivative, by saying 3f prime plus 4h prime. So for f prime, I'm using this number. And for h prime, I'm using this number. So 3 times -1 plus 4 times -3. Which two are harder? B, because you need what? The quotient rule. And C, because you need the product rule. So let me, which one do you want me to do, Tatiana, the quotient or the product? I'll do the product. Yep, I'm gonna do C. So to take the derivative of f times h, I do the derivative of f times h plus f times the derivative of h. So I need f prime. That was the purple one. I need h prime. That was the yellow one. I need h. That was the green one. And I need f. That was the orange one. So I'm going to say f prime -1 times h -1 plus f -5 times h prime -3. Let's give away all the secrets now, right? Is that okay? All right, guys, have a great weekend. Remember, no class Monday, no handwritten quiz Monday. Do your quiz now so you can have a long weekend. They're still doing the vaccine bonuses until the end of September or something. Oh, I'm adding Friday to my list of times I'm in the AEC. So I'll be there from 2 to 3 on Wednesdays and 2 to 3 on Fridays.
Thank you guys, everyone. Thank you.
Okay, let's check. -2, why the negative? I think this is gonna be plus. Because when I bring it up, it's gonna be -4. And then negative times -4 will make plus 4. So try that with a plus first. D. Okay. So the derivative is gonna look like, oh wait, let me stop the recording.
Just really quickly, what did you say again?